Good morning. Welcome back to the Thermodynamics lecture 4. Today we will see some more enthalpy basics. Enthalpy changes during the phase change. Normally we consider the ice, water, steam. So standard definition, yes, I will repeat, but I will tell the first this thing. The quantity required for melting of the ice, that is will be carried out at 0 degree centigrade, means there will not be any change in temperature, there is no change of the pressure also. So how much is the quantity of the for the standard conditions? That is the heat of fusion. Similarly, for the evaporation, it is evaporation. The standard sentence we will see enthalpy change. Enthalpy change. Enthalpy change for melting, that accompanies melting of here 1 mole of solid, 1 mole of solid in a standard conditions. Standard called standard molar enthalpy of fusion. Symbol what we are writing is F delta fusion, FUS H. This is standard condition is we are writing as minus top. Similarly, for evaporation, amount of heat required or quantity of heat required for 1 mole, again 1 mole of, there it is solid, here it is a liquid. In standard condition same, and temperature is constant, pressure is constant. Under standard conditions it is called standard molar enthalpy of here vaporization. Remember, that is solid, this is liquid, that is at particular same constant temperature and pressure, here also same amount of heat required. Here it is delta VAP and H minus. This is the phase changes requires. Normally it will be used for the water, steam and all. Now one more we will see this term, the standard enthalpy of formation. Standard, this is very important, listen carefully. Standard enthalpy of formation means this one. Here the standard, again the standard enthalpy change for formation of 1 mole, formation of 1 mole important of a compound. One more important one is from its elements, from its elements. Formation of a compound of 1 mole compound from its elements. Standard condition is standard enthalpy of formation, and the symbol normally what writing is delta formation H standard condition, right? Very simple. Now we will see, then we will see the confusion statements and all. Simple example is hydrogen plus half O2. I am not balancing, see carefully, and H2O. And delta formation of H2O is, that means H minus equal to minus 285, that means it is a exothermic, minus 280.5, some 8 kilojoules per mole. Similarly, graphite C plus 2 height gives CH4, then delta formation H minus gives some value, that is nothing but minus 74 kilojoules and all. One more this thing, carefully see, C plus half O2 gives of O2 plus 3H2 gives C2H5OH and heat of formation, delta heat of formation, delta equal to minus 277 kilojoule per mole and all. Now in all the cases the condition is fulfilled. 1 mole is formed, 1 mole is formed, 1 mole is formed. From its elements, hydrogen of oxygen, carbon hydrogen, carbon oxygen hydrogen. So this is satisfied. Now tell me how it is different from heat of reaction. Can I say these three are the heat of reactions only? You remember the yesterday's this thing, heat of reaction is nothing but the enthalpy of the products minus enthalpy of the reactants. So same. So the answer or meaning is it is a special case. In these cases, heat of formation is equal to heat of reaction, but not necessarily all the time. The contrary means the corollary means the contrary is not same. In these special cases, heat of formation and heat of reaction is same. But in normal conditions, heat of reaction means products enthalpy minus reactants enthalpy. Now, one more typical you see. Typical. Can I call this is a formation of CaO, calcium oxide, plus CO2 gives calcium carbonate. And enthalpy formation, some value will be there. H minus is minus 178 kilojoules per mole. Can I call this is a heat of formation? Because simply it is forming, 1 mole is forming, but it is not fulfilling the formation from its elements. Remember all the time, 1 mole has to be formed and it should form from its own elements. It is not an element, calcium oxide is not an element, carbon dioxide is not. So it is not a heat of formation reaction. Right. Okay. Now one more typical example I will tell. Hydrogen plus bromine gives 2HBr. 2HBr and delta formation of H minus gives value of some 72.6 I think. Is it the same? Can I call it this is a heat of formation reaction? Here also it is again no. Why? Hydrogen is an element, agreed. Bromine is an element, agreed. It is forming from its elements, agreed. But it is not formed as 1 molar. It is formed as 2 moles. So in this case, delta reaction, standard reaction enthalpy equal to 2 delta formation H minus. Understood? So I think it is now very clear. These are the special cases in the reaction. It is the same. Here this is not at all a heat of formation at all, because it is not formed from its elements. Here it has formed from the elements, but 2 moles has formed. It has to form from elements and 1 mole. That is only heat of formation. Very clear, because heat of formation we are going to see many times, most of the time, all these things. Right. Now, coming back to this thing, one more this thing, whether enthalpy is a state function or not. That means enthalpy is a what you call extensive property or intensive property, whether it is depending on this thing. A simple example we'll see how to carry out. Take ferrous oxide Fe2O3 plus 3 hydrogens gives 2Fe plus 3H2O, a balanced equation. You call it as equation 1, right? All are formed. Here I am writing delta reaction standard is equal to, you know, the products enthalpy minus this thing. So 3 products enthalpy is H2O formation, H minus for H2O, and Fe it is 0 minus for H2 it is 0 minus for delta formation of Fe2O3. This value if you calculate, that will comes to some 33 kilojoules or something like that. Just standard formations you write. The most important one is different. Now the same equation I am writing as Fe2O3 plus 3H2, the same equation. Here I am writing Fe, so division by Fe is half Fe2 and half Fe, 2 Fe plus 3H2, right? I am division by this thing. Now 3 by 2 H2O, division by 2, 3 by 2 H2 also. So in this case, will it be the same as the above one? Because now this is also balanced equation, this is also balanced equation. Now where delta reactants, heat of reaction is products minus enthalpy minus the reactants. Here also if I am writing, it will be, if you see, it will be the half of the amount. That means around it will be some 16.5, half, 16.5 kilojoules. The meaning what we say, it is a enthalpy is a extensive property, means it depends upon the quantity. So please remember that one. Right. Now similarly calcium carbonate, this if you recall back the stoichiometric equation, calcium carbonate, that means calcium carbonate is actually a decomposition equation, but it is not a redox reaction. Remember, see, correlation is always the calcium carbonate and such type of things are special. Okay, so tomorrow we'll see some more enthalpy of combustion and then further and all these things. Or tomorrow we'll do some calculations, some problems, so that you can understand the subject more deeply. Thank you.